thrilled with a 3 on this side of the room. Fighting for a 5, that side of the room, please. All right. I'm starting with the 3 people. Okay. Don't worry, I'm still working on this one. All right. So whether you are thrilled with a 3 or fighting for the 5, I want everybody working on this one. Okay, this is in the free response questions, problem number 1. When I think back on yesterday and the way I designed that lesson, if I pull out and I think about what happened, you guys divided, and then people that were over here and fighting for a 5 got like part A maybe, and then at part B, you were just over on that side of the room in the same part of this conversation that we were in. This problem, if you are fighting for a 5, should be much more manageable as a starting question. That's where I blew it yesterday. So all the friends and you guys are thrilled with a 3, fighting for a 5. Help each other out, use the survival guide, but it needs to stay at whisper mode. For the next 15 minutes, the 8 of us are focused.
Can I sign a petition?
Can you sign up for petition? No. All right, so let's get rocking and rolling here. So, let's get a little active here. What are we going to do? Read through this problem, mark it up. All the things you would normally do if this was the AP exam. Let's say you wouldn't actually do that for the AP exam.
Yeah, my panic monster died.
Mark it up.
Well, how can I do that? My panic monster died.
I get both of these back. All right, Jennifer, give me some important information that I just saw you highlight with your pretty big marker.
X equals 7, Z equals 0?
Okay, at x equals 7, t is equal to 0, this is that initial condition, right? They're like, hey, this is the thing you know for sure. I know that when t equals 0, x equals 7, initial condition. Jasmine, anything else that you know for sure? Ah, okay. How about David? Anything else that left off the page at you as being really important?
Use all the units, which is meters and seconds.
Oh, definitely. I want to pay attention to the fact that I have units of seconds for time, meters per second. Give me one more thing.
Differentiable function.
The function is differentiable. Jennifer, what does that mean? Perfect. It means that the derivative exists. It also means one more really important thing. Differentiable means the derivative exists, but for the derivative to exist, the other thing you have to know about the function, Anthony, it has to be continuous. Okay. Honestly, I think we've kind of stripped out all the stuff right now. So, A, estimate the acceleration of the particle at time t equals 36 seconds, and include the units. Pull back just a little bit so I can have some time to write. Good. All right. I want acceleration at time 36. Now I'm pretty confident you guys know how to find acceleration. You want to find acceleration? What are we going to do? You're going to find the derivative at 36. There's a problem though. We don't have an equation. You cannot actually find it, but you do know that the derivative of velocity is acceleration, and that's good to know. Maybe that gets you a point, maybe it doesn't get you a point. But if you read the question carefully, they didn't actually say find the derivative of the velocity. They didn't say find it, they said what? What's the verb? Estimate. They want you to estimate the derivative, and the way that you're going to estimate the derivative is we're actually going to look at how the velocity changes over a time interval. Rather than finding instantaneous velocity, like how did it change at that moment, we're going to look at change in velocity over change in time, and we have to use an interval that contains 36. There's only one interval that really makes any sense here.
32.
Right, we're going to go from 32 to 40. So I'm going to set this up and say velocity at 40 minus velocity at 32 divided by the difference in 40 minus 32. Now, question for Jose. Can you stop here? Is this an acceptable answer?
Yes.
Everybody agree? Abraham, why not?
Oh, because it says estimate and it's not like a legitimate estimation.
It's not a, tell me, what do you mean it's not a legitimate estimation?
Oh, and also it doesn't have units of measurement.
Okay, we don't have units of measurement. I think Jose's thinking, well, we've got numbers, right? And so we don't bother simplifying. But the thing is, you actually don't have numbers yet. The velocity at 40, you have to tell me what is the velocity at 40. The velocity at 40
7.
is 7, right? 7 minus velocity at 32.
-4.
-4 over 40 minus 32. Jose, can you stop now?
Yes.
Are these all numbers?
Take those.
Yes, they're all numbers. There's no need to go any further. If you want to, and you say, oh, but I know 7 minus -4 is 11. Great. 40 minus 32 is 8. Great. No need to. But I do need units. Velocity in the numerator, time in the denominator. Jennifer, what do those units have to be? Change in velocity, change in time. Meters per second is how we measure velocity, right? Denominator? Seconds. And does that make sense? Does that fit what you guys know about physics?
Triple negative.
I don't have a triple negative, my finger got in the way. Meters per second is the right units for acceleration. So meters per second or meters per second squared. Remember,
So if that was, we said that if the acceleration is going to be the derivative of velocity, why do we use that in the graph? Because we didn't find the derivative, have we?
because we can't find the derivative. You could only actually find the derivative if you had an equation.
Okay. So
And you don't
subtracting
have
the
an
velocity-
equation, you have data points.
Subtracting those velocities gets us an acceleration.
It gets us how the velocity changes over how the time changed.
Now that's slow. pretty
Right.
much.
Because this means slope of tangent line, this here is slope of secant line, and that's how we're going to approximate. All right, part B. Let me get out of your way and give you guys a little bit of time here. Okay, integral from 20 to 40. This is a 3-point question. I'll check back in with you guys in 1 minute.
The distance from 20 to 40. Trapezoidal. So with 3 subintervals, so 40 minus 20. 20 divided by.
Well, you fix your survival guide. Not that blue thing. No.
So, yo, do you remember the trapezoidal thing? But it's every 20. You remember the trapezoidal?
All right, integral from 20 to 40, v of t dt for all the friends that are up here. So we get a 3-point question shown up here. Number, and again, they're never going to tell you how many points. Okay. First question, what does it actually mean? What does this integral mean in this problem? I'm integrating velocity from 20 to 40. It means displacement. Okay. This means displacement. Now with displacement, we need to be really careful. I want to get a complete thought here. So this is the displacement. You're on the board. Well, let's keep going. Displacement from where to where? Yeah, just that's easy, right? From t equals 20 to t equals 40. That's going to get you a point, But in this problem, they are specific. They want units now. What are those units have to be? They have to be, Jennifer, what did you say? So displacement is a measure of how position changed. I was here, now I'm over here. Displacement is measuring distance. So the units for distance would have to be meters. So this is in meters. Ramir, do you have a question? Okay, but everybody's good? Displacement in meters. Now, here's the thing. Way back in the day, we used to do this all the time. Right, you want to go from 20 to 40, okay, and I saw in some papers, you're like, oh, I'm going to go from 20 to 40. Got it. Well, how am I going to go from 20 to 40? There are lots of things we used to do. We used to say things like, go from 20 to 40, and this is going to sound familiar, using 4 rectangles of equal width. And you'd say, oh, well, the distance is 20. I want 4 rectangles of equal width, so each rectangle has a width of 5. And you would do your partition and say 20, 25, 30, 35, 40. Abraham, how do we want to go from 20 to 40 this time? They want 3 subintervals. Now earlier I heard somebody say do 40 minus 20 and divide it by 3. That would be right if the question was 3 equal thingies. They're not equal. You've got to use the data points that you got. So if I'm going to go from 20 to 40, the data points that I have, I know at 25 what the velocity is, and I know at 32 what the velocity is, but those are the only ones I know. Some of you guys might even like do a little like, oh, let me plot the points so I can make my trapezoids. We used to do that all the time, right? And you say, find the area, find the area, find the area. Area of a trapezoid, Jennifer in the back. How would you find area of a trapezoid? Okay, thank you for the honesty. Somebody help her out. Area of a trapezoid. Anthony, how do you do that? Wait, one more time? 1/2. 1/2 B1 plus B2 times the height. Okay? So if I'm going to estimate the integral from 20 to 40 v of t dt, well that's approximately 1/2 the first base. I'm asking how tall is this side over here at time 20? And the answer? Right, this graph doesn't match those data points. But at 20, what's the velocity?
Negative 10.
Negative 10. So 1/2 of negative 10, what is it, plus negative 8? Negative 10 plus negative 8.
Plus negative 4.
Be careful. This is the base. This is the second base. The height, and I think this is always the weird thing with the trapezoids. Right? We're saying like base 1, here's base 2. The height has to be perpendicular to those two, so the height is actually the length. So, what we got, 5? Jennifer Ortega, you doing okay now? So we got the first one. Can you tell me about the second trapezoid?
Negative 8 plus negative 4.
Oh, I was going for Jennifer, but I wasn't specific. Sorry, Jennifer. Yep. Get me the area for the second trapezoid. 1/2. Yep. Negative 8. So we're going, we've already gone from 20 to 25. Now we're covering from 25 to 32. I need the base, right? So it's the base, the other base, times the distance in between. So negative 8 plus negative 4 times 7 plus, Jasmine, can you finish it off? What's the third trapezoid?
1/2
1/2.
times negative 4.
1/2 times what?
Negative 4
Negative 4
plus 7
plus 7
times
times, oh God, times 8. Done. Don't simplify. Jose, are you confident that it's okay to stop here? All right, good. We got one more that we're going to do together. Part C, on the time interval 0 less than or equal to t less than or equal to 40, must the particle change direction? If the answer is yes, tell me where it has to change direction, and tell me when it has to change direction.
Oh, right here, whenever I change. I'll sit there. When it changes from
And Jonathan, if you're eavesdropping, hi.
8 in between 8 to
All right, Rombie, I've frozen you out for a little while. What are your thoughts on part C? Does the particle have to change direction?
Wait, so
Yes.
it's from it does change direction?
Okay, first of all, let's answer their question, right? The College Board is really specific on this. The first part of the question, on this interval, must the particle change direction? Yes! Why?
A change in direction indicates the velocity changes from positive to negative or negative to positive.
Okay, the particle must change direction because the velocity changes positive to negative. Okay? Where? Where does that happen?
At well, we don't know the exact point, but we
Yeah,
know
you don't know where exactly, but the thing that you know with confidence, Jose, where does the velocity change from positive to negative?
8:20.
On the interval 8, 20. And there's probably some other place where there's a change. Abraham, or where else?
From 32 to 40.
And V of t changes negative to positive on, what did you say?
32 to 40.
32 to 40. Now that's good. That is an answer to their question. You've answered it correctly. Yes, the particle changes direction. And you know on what intervals. There is something super important, super, oh my God, important. If you are going to make this work, there's something that has to be true about the function. There's something really, really, really. We are implying that you are crossing the x-axis, that your velocity was once above the x-axis and then at another time it is below the x-axis, and so at some point it's actually equal to 0 because, oh, I'm sorry, what?
The graph is continuous.
The graph is continuous, more important, more specific.
The function. V of t.
Yeah, so the function v of t is continuous. That is the thing. If you don't have continuity, your argument kind of falls apart. Because what if your graph did like this?
True.
Right? You could go from being positive to being negative without ever actually changing direction, being equal to 0. These are all the things. Okay? So at this point, it's time to switch. You all are going to start working on this weekend's homework, which is called multiple choice questions. All of which involving velocity. Some of these are going to be easier and kinder than others. So you guys have the next 15 minutes to get started on this. Okay, friends that are fighting for a 5, you guys are coming on over here. We're moving on to a different problem. You have got to go so fast. Because this and no binder today, really not getting into the heart. All right, fighting for a 5, friends. Huh? Do I want to pass? I want you all to pass, yes. Thank you for asking that important question. All right. All right, fighting for a 5, friends. Everybody still doing all right? I hope this felt like a kinder start of a problem than yesterday's problem. I think yesterday I just chose poorly. I'm not expecting that on any of these problems, when you're doing this, you're going to be like, slam dunk, I get all 9 points. That's not going to happen right now. In fact, that might not happen, period. Right? The goal is for you guys to like really stretch the smarticle particles, help each other out, use the survival guide, learn from one another as much as you can, and then we're always going to end with a much harder problem. So, for several years, the College Board has done these particle motion questions. They ask about position, velocity, acceleration, all the things. The last couple of years, they have really been pushing themselves and your generation of teenagers. Because, you know, my generation, 1 particle was enough for us. Your generation, they start asking about 2 particles, or 2 little cats, or a cat and a dog. And sometimes the cat and the dog are going in the same direction. If the cat and the dog are moving in the same direction, that means they're both going to the right or they're both going to the left. What do you know? What's the same? They're both going to the right. They're both going to the left. The velocity is not increasing. If both the cat and the dog are going to the right, the thing that is the same, not even their speed, their velocity is, both of them have a positive velocity. Both of them have a negative velocity. What if the cat and the dog are running towards one another? They have opposite velocities, right? That is the same if they're going towards one another or going away from one another. Now if they're at the same spot, probably not so good for the cat here. If the cat and the dog are at the same spot, what's the same? If they're at the same spot, their position is equal to each other. Right? All the things now, you've got to think about, oh my God, cat and dog, 2 particles. Here is our first problem. All right, 2 particles moving along the x-axis for the time interval 0 less than or equal to t less than or equal to 5. Position of particle r is given by r of t equals 2 sine pi t over 3. Velocity of particle p is given by vp of t equals 3t squared minus 8t plus 4. 2 particles. Good luck. Good luck. It might not be such a bad idea to organize the thoughts a little bit here. So when I was thinking about this problem earlier, I said, okay, I've got particle P, I've got particle R, I've got position information about one, I've got velocity information about another. What do we know? We've got, what do we know? We've got velocity information on particle P. I've got position information on R? R t equals 2 sine pi t equal 3. Jonathan, if I wanted to know the acceleration of particle P, what would you do? Find the derivative, get an answer done, right? Adriana, what if I wanted to know the acceleration of particle R?
Acceleration?
Acceleration.
We need to find the second derivative?
Second derivative, right? So you'd have to go down 2 derivatives. What if I wanted to know if they're moving in the same direction? Jonathan, what would you need to know? The antiderivative of velocity would give you position. It wouldn't tell you if they're moving in the same direction. Because the idea is that they are moving. Yeah.
On derivative for position, and at a certain point find that they have the same sign for that velocity.
Find the derivative of the position to get velocity, and then we're going to have a velocity comparison conversation, right? Also, maybe I asked the question, who's going faster, the cat or the dog? Those are velocity conversations that we're going to be having, okay? All right, what if the question was about acceleration? I'm sorry, acceleration, speed. The speed of particle P, is the speed of particle P increasing? Eunice, what would you do? How would you decide that?
The velocity and acceleration, they will have to have the same sign.
So for particle P, we'd look at velocity and we'd go one step further to acceleration and we'd say, what are the signs? And if the signs are the same, our conclusion would be,
Increasing.
if the velocity and acceleration have the same sign, you would say speed is increasing. Everybody okay? Okay, good. Moving in a good direction here. Okay, so part A, let's do it. Part A, find all values of t for which particle p is moving to the right. P moving to the right. Jonathan, what are your thoughts here?
Find the derivative of condition.
Find the derivative of position for particle E, right?
Yeah.
But what is the derivative of position?
Velocity.
It would be velocity. Okay, so hey, good news. Don't even have to find a derivative. Okay, derivative, 3t squared minus 8t plus 4. That's my velocity expression. I want to know if I'm moving to the right. Martyr, what are your thoughts here? How would you figure out if I'm moving to the right? What would you do? I want to give Martyr just a second here. If the particle's moving to the right, you know something about the velocity. Hold on one second, Eunice. I'm going to the right, Martyr. Go back to that summary sheet if you need to. Is it okay if Eunice helps you out a little bit?
Yeah.
Okay. You're like, yes, please. Eunice, help me out.
The velocity is positive.
The velocity has to be positive. Martyr, you okay? Okay. Now I'm going to answer the question, when's the velocity positive? What you going to do?
Number line.
We're going to do a number line test, right? So for those of you that are good with the number line test, just go, go, go. Okay, so if I do a number line test, I'm just going to do this out loud for the friends at home. I'm going to take that velocity, I'm going to set it equal to 0. And I'm going to solve this equation. And yes, I'm a fast factor, 3t minus 2, t minus 2. I've got to set each of these equal to 0. T equals 2/3, and t equals 2. These are the places where the particle is at rest, the velocity is equal to 0. What I heard somebody say is do a number line test. Great. So here's my velocity. I'm at 2/3, I'm at 2, velocity equal to 0, velocity equal to 0. Christian, what's your next move here?
Find points between, after, in between, and before those to find if it's positive.
Oh, wow, you hit all the places, right? Test value, test value, test value. Choose them wisely. A good test value before 2/3?
0.
0, duh. Okay, if I'm gonna plug in 0, let's go and plug it into a nice convenient place like the factored form. And remember, I don't wanna hear a number out of you, I just wanna know sign. At time 0, if t equals 0 is my test value, what's our conclusion there? This guy's negative, so conclusion positive. Between 2/3 and 2, good test value.
1.
1, plug it in. What is this? Positive here, negative here. After 2, maybe 3, maybe 4, doesn't matter to me. Plug in 3, positive, positive, positive. Okay, need a good conclusion. When is the particle moving to the right? When the velocity is positive, sure. Last class somebody said for all values of t less than 2/3 and all values of t greater than 2. What do we think about this? I see a whole lot of head shaking like, no, that's wrong. Martyr. Right, it's the fancy phrase here, domain restriction. We're only going to look from 0 to 5. And so I didn't do it in the beginning because I wanted us to have the conversation now. Normally when I have a domain restriction, I put my blinders on right away and I'm like, do not think outside of 0 to 5. Now we answer the question. Particle moving to the right. Moving to the right. When VP of t is positive, when's that happening? From 0 to 2/3. And from 2 to 5, I'm deliberately leaving out parentheses and brackets because I want us to have a good conversation here. Eunice, what do you think? What do you think about parentheses and brackets? If I look at the number line, where's the velocity positive? Eunice, is it okay if Adriana helps you out? Adriana, help her out.
I think it will be a bracket next before the 0,
Okay,
and then a parentheses on the 2/3,
on the 2/3
and then a parentheses on the 2, and a bracket on the 5.
and the bracket on the 5. Because at 0 and 5, the velocity is positive, but at 2/3 and 2, the velocity is equal to 0. That doesn't mean moving to the right. That means I'm at rest, which I will be soon. Okay, good. All the friends go to the part A? All right, try part B. See what you can do. Anybody else doing particle R? Or is everybody doing particle P? Particle P. All right, particle P. I've got my velocity, 3t squared minus 8t plus 4. My acceleration, everybody's at 16 minus 8. Okay, velocity at time 1 is going to be 3 minus 8 plus 4. Acceleration at time 1 is 6 minus 8. I know between August and now, I've always said, don't simplify, don't simplify, don't simplify. Guess what? You have to do some simplifying here. You need to be able to tell me with confidence, positive or negative. And so this guy here, negative. I don't even need to tell you negative what, just tell me negative. If there is any chance you're going to get this wrong, just tell me negative. Over here, negative. Conclusion? Speed is, I heard increasing. Now here's the thing. This is right, but it's not right enough. Eunice? At t equals 1. You know what? Still not right enough. And the problem is, in this 2-particle world, you need to be more specific. The speed of what is increasing at t equals 1? The speed of particle P. All right, Eunice, you got things under control back there? Okay, friends, we've got 12 multiple choice questions that we're doing this weekend. I'm just gonna go for a walk. Those of you that are interested in sticking around for a little while, great. I'm just gonna go out to the Maverick Green for a little bit and stretch my legs and enjoy some water. If anybody wants to go with me. Just saying. Getting a little thirsty. I think we're all getting thirsty and we want water at the Maverick Green.
No, I got water.
Oh, at the Maverick Green.
I'm gonna be at Maverick Green.
Are you lying?
Just put it on.
Are you gonna put him on lock?
No.
Oh, you're gonna have.
So what? Yeah.